Hello everyone, in this video we're going to talk about piecewise functions. So what is a piecewise function? It is just a function that is defined by two or more equations, and we kind of look like pieces, right? So each piece of the function applies to a different part of its domain, and we have an example here below. Okay, so here is our piecewise function written over here. So it says f of x is equal to x minus 2 if x is less than or equal to 0, and f of x is equal to 2x plus 1 if x is greater than 0. So this part right here is the different domains, right? So if our domain, or if our x values are less than or equal to 0, then we're going to use the first equation. If our x values or our domain is greater than 0, then we're going to use this second equation. So we can graph both of these. Both of these equations are linear, and so we graph them, but instead of it being a line, it's like a ray. And so in this case, we have an end point because our domain is being restricted to only a certain portion of the graph. So for x minus 2, notice that our y-intercept here is at -2, and our slope is 1, right? So down 1, left 1, so we still have a slope of 1. Since this was an or equal to inequality symbol, we have a closed circle at the end of our graph. For the other piece of our function, we had just a greater than symbol, so we have an open circle. The y-intercept was 1, so positive 1 is where our point goes, and our slope is 2, so up 2 and right 1. Okay, so that's what an example looks like. So we're going to do three things with piecewise functions. We're going to evaluate, we're going to graph, and we're going to write the function from a graph. So for example 1, we're just going to evaluate a piecewise function. So this function has actually three pieces. So we have f of x equals 3, f of x equals x plus 2, and f of x equals 4x, right? And this is where the domain is split into pieces, okay? So we're going to look at these numbers over here on the right side, and essentially if this number that's in parentheses falls in, if it's less than -2, then we're going to use this first equation. If it's between -2 and 5, we're going to use the second one, and if it is greater than 5, we're going to use the third one, okay? So for number 1, we have the f of -8, so -8 is less than 2, so we're just going to say this is equal to 3. The f of -2, well, that would fall in our second equation, so -2 plus 2 would be 0. The f of 0 would also fall in the second equation, so 0 plus 2 is 2. And 3 would fall into the second equation, so 3 plus 2 is 5. F of 5 would also fit into the second equation, so 5 plus 2 would be 7. And x is greater than 5, so the f of 10 would fit into our last equation because 10 is greater than 5. 4 times 10 is 40. And that's how we evaluate a piecewise function. All right, so now let's look at how to graph a piecewise function. So we are going to graph y equals -x minus 4 if x is less than 0. And we're going to graph x, or y equals x, if x is greater than or equal to 0. Okay, so two parts to our graph here, and then we're going to describe the domain and range. So let's look at the first one, y equals -x minus 4. And it says if x is less than 0. So when we have less than or greater than 0, really our y-axis is kind of like our separator point. So here we have x is less than 0, so we know it's going to be on the left side of our graph. So -x minus 4, the y-intercept would be at -1, 2, 3, 4, right? So since our y-intercept would be there, I am going to put an open circle at -4 because it's a less than symbol. It's not or equal to. Our slope is -1, so we're going to go up 1 and left 1, right? So up and left. So notice how our line is it's going downhill, right? If I was looking at it from left to right. And so that is our first piece there. Okay, so this would be y equals -x minus 4 when x is less than 0. Okay, so now the second piece is when x is greater than or equal to 0. So that's x values to the right. So our graph is just y equals x. So the y-intercept there would be 0. So we're going to put a closed circle on 0 because it's or equal to. And we're just going to go up 1 and right 1 for our slope. All right, and so this one would be y equals x when x is greater than or equal to 0. Okay, so now let's talk about the domain and the range. So the domain is, remember, left to right. So both of these graphs are going to extend in opposite directions forever. So our domain here is just going to be all real numbers. And our range now, both of these graphs are going in the upwards direction, right? So we're gonna go up forever, but we have a lowest point, right? Our lowest point is here at -4. So we're gonna say y is greater than -4, right? And the reason we're gonna say greater than is because that is a closed circle, or excuse me, that is an open circle on -4. And so we're just gonna say our range is values that are greater than -4, right? We don't include -4, okay? And lastly, we're going to write a piecewise function. So we'll call it f of x, and we'll draw our open set bracket there. And notice we have 3 pieces, okay? So we're going to start at the leftmost point, or the leftmost piece, and work our way to the right. So kind of a good idea for this would be to almost like extend these lines so that they cross the y-axis so that we can see what the y-intercept is. So in particular, if I look at this line right here, if I were to extend it, right, I can see where it would cross the y-axis, and that's at -2. So I know it's going to end with -2. So now my slope is up 1 and left 1. So that's going to be a -1 slope. So we're going to say -x minus 2. Right, that would be the equation of my line. And so now I'm going to take away this extra part. And now let's talk about the domain, right? So these are any values that are less than or equal, because we have a closed circle, and this is -2. Okay, so anything less than or equal to -2, we would use that function. Okay, the next one we have is just a horizontal line, so that's got to be equal to a number, right? And so it passes through 2, so we're just going to say y equals 2. If, and we have open circles, so it's just going to be our less than symbol. And this one's going to look like a compound inequality because it's between -2 and 1. So if we're between -2 and 1, so x is greater than -2 and less than 1. And our last equation, we can do like what we did earlier and kind of extend it down so that we can see what the y-intercept would be. And that's going to be -1, 2, 3. And our slope is up 2 and right 1. So 2x minus 3, if we can take away this extra piece. And right here, this is 1 on the x-axis. So we're going to say if x is greater than or equal to 1. And those are piecewise functions.